Hi everyone, welcome back to Array series. Hope you're doing good. This is Mahesh. In this video, we will look into a Leetcode problem, which is 1752. Check if array is sorted and rotated. Okay, so let us try to understand the problem first. So this problem statement says given an array nums, return true if the array was originally sorted in non-decreasing order, which means increasing order, then rotated some number of positions including 0, otherwise return false. Okay, there may be duplicates in the original array, and note, an array A rotated by x positions result in an array B of the same length. Okay, now let us try to understand this problem a little bit more. Let's go to the editor view. So as usual, these are the steps we are going to follow throughout our series. We will understand the problem statement, we will understand the constraint, then we will pause the video and wait for, think for some solution, and then we will further proceed with brute force solution and the most optimal one. So with that, let us try to understand the problem. Okay, so now if you see, there is an example here which is 3 4 5 1 2. So this is a nums array which contains these numbers. Now if you see, the original array is 1 2 3 4 and 5. Then what they have done, they have rotated the elements towards some position basically. Okay, so now what I will do, I'll move 1 to the end. So that time 2 shifts here, 3 4 5, then 1 comes at the end. Okay, now again I'll move this 2 at the end. So if that is the case, then 3 in the beginning, then 4 5 1 and 2. If you see, originally array was in its sorted position. Okay, now after rotating for 2 times from the left towards right, that time what happened, we got this particular array. Okay, so what we need to find, whether this given array is a proper sorted array with some rotations, hope that is clear. And constraints, we already saw there can be some duplicates in the array, and there can be more than one element. So that then only we will be able to sort and rotate the array. Okay, so with that understanding, now you can pause for a second and you can think for any possible solution. Okay, so now let us try to understand what interviewer will be expecting. So basically this problem, he will be expecting you to solve in order n time complexity. So that means we need to solve this problem in only one iteration. Okay, so with that understanding, let's proceed with the brute force implementation. So now how to come up with the solution? So if you see numbers, it is 3 4 5 1 2. So what you understood, we have rotated it for 2 times, correct, right? So that's what we saw here. Now what we will do, we will keep on rotating it for n number of times. What exactly is n here? N is basically our length of array. So length of array. Okay, so now if we rotate it for n number of times, in any one rotation, we will get a proper sorted array. So we can see that here. Now this is our original array. Okay, now what I will do, I will rotate, I will push 3 towards end. So what it becomes, 4 5 1 2 and 3. So this is my first rotation. Okay, now is it sorted? No. Then what I will do, I will again push 4 towards end, then it becomes 5 1 2 3 and 4 at the end. This is my second rotation. Is it sorted? No. Then again I will do that. Now push 5 towards end, then it becomes 1 2 3 4 and 5. Okay, what we got? We got a proper sorted array. So if this is the case, whenever we get a proper sorted array, then we will simply say it is a sorted and rotated array. Okay, so this is a positive case. Now assume my array is not sorted. So this is my sorted array. So I will change the order a little bit in this one only. This is our negative case. So what I will do, I will take 2 at the first and then 3, 4, 5. Then I'll rotate it 2 times. Okay. So maybe 2 I'll push, then 1. So it becomes 3, 4, 5, then 2 and then 1. Okay. So this is our rotated array, correct, right? I mean, this is our unsorted array and this is our rotated array by 2 times. Okay, so now let us try to find all the possible rotations for this particular array. You can ignore this one for now. Okay, so now what I will do, I'll push 3 at the end. So basically how many times we have to do? We have to do it for n times and check. So after n times, so again the original array starts repeating. We will check that here. Now I'll push 3 at the end. So 4, 5, 2, 1 and 3. This is my first rotation. Okay, then I'll push 4, 5, 2, 1, 3 and 4. This is my second rotation. Now 2, 1, 3, 4, 5. This is my third. Then 1, 3, 4, 5, 2. This is my fourth rotation. Again, what I will do, I will push it. I'll push 1 towards the end. Then this becomes 3, 4, 5, 2 and 1. If you see now with the fifth rotation, again our original array starts appearing. If you see, none of the array is sorted. None of the array is sorted after rotating. So this is not a sorted array. This is not a sorted and rotated array. So this is how we conclude. Okay. So now if that is the case, here what is the time complexity? So on each rotation, what we are doing, we are pushing one element towards end and we are shifting all the elements towards the left. So if that is the case, and if that is the case, it is of order n. Each rotation is of order n. But how many rotations we are doing? We are doing n number of rotations. We are doing n number of rotations. That's where it becomes of order n square time complexity. Order n square time complexity. What is the space complexity? We are doing it in the same array, so it is of order 1. Okay, let us look into the pseudo code for this one. So I will say is valid, or maybe what we can take it as check. Then I'll pass nums array. Okay, now let n be nums dot length. This is the length of the array. Okay, after this what we will do, we will try to generate the rotations, n rotations basically. Okay, so here what we did, we literally generated the rotations and we saw. But in the code, if JavaScript provides us slice option. JavaScript provides us slice option. So slice means it will take start and end. Then what it will give you? It will give you part of the array. It will give you part of the array. So what you can do, you can say this is for this rotation. What I will do, I will take this is first part and this is second part. Okay, then what I will do, I will concatenate this array and this array. So that way we will get this part. Then again in the next iteration, I will slice this much and I will slice this much. Then I will concatenate this array, then this array. Then what we get this particular rotation. So in JavaScript, we can do that way. But in Java, so we will have to mimic this rotation. So we are not really rotating it. So what we need to do, we need to mimic this process. So that is called mathematically modulo operation, something like that. So what you can do, so here, if you take this example, let me take that here again, 3, 4, 5, 2, 1. If I want to send this at the end, then my rotated array will have this element at the first. Okay, so this element will go at the end, so it should come at the end, right? So if that is the case, if it is the first element and if it has to be the last element, then once my array reaches this position, then again I need to start from the beginning. Correct, right? Because I am starting from the first index and I am iterating for n times, so it becomes n plus 1 iterations, right? So when it is n plus 1 iteration, then I will have to somehow take out this n part. So what I will do, I will do a modulo n operation. So if that is the case, it starts from first index and it ends at the 0th index. If you want to start the element at second index, you can do the same thing, because whenever it crosses n minus 1th index, again we need to start from 0th index. So for that we will do modulo operation. So we will use that logic here and we will try to check if the array is sorted whenever we do rotation. So for that, what we will do, we will do all the possible rotation, that is basically n rotation. So I equal to 0, I less than n, I plus plus. Okay, then we will check if is sorted, and we will send this nums and we will need a sorting index. Basically, I mean, that will be the starting point. So initially what we have to do, we have to take out only one element and then we have to start from the first index. In the next iteration we will have to start from the second iteration and something like that. Okay, then what we can do, we can check whether the array is sorted or no. So before understanding that, we will also need to understand how to get to know array is sorted. So if array is sorted something like this, then if you see this element, it is greater than this element. If you see this element, it is greater than this element. If you see this element, this is greater than this element. Correct, right? So when the elements are in their increasing order, then only we will say that it is a sorted array. So this is a basic common understanding for us. So we will keep this in mind. Now, if the array is sorted from index I, okay, that is the starting index. So that's where we rotate, right? Then we will pass that and then we will check if it is equivalent to true. Then if any one combination, any one rotated array is true, then we will simply return true. Okay, if that is not the case, then after the for loop we will simply return false. Why? Because none of the combination is sorted. So now we need this is sorted method. So we will write that. So I don't mention any type here. I'll simply take is sorted and we get nums array and also rotation index. This is rotation index. Okay. Now how do we check? Let us again take n equal to nums dot length. Okay, now we will iterate from, see, if 5, 2, 1, 3, 4 is my original array. If I want to rotate it, then this becomes my starting index, correct, right? Then from here, I need to check its previous element. So its previous element means this is my 2, 1, 3, 4, 5. So instead of 2, I'll start from 1. I'll check whether it is greater than 2. Then the next element, whether it is greater than the previous element, something like this. So I will use a for loop for j equal to 1, j less than n, j plus plus, or even we can take I also. That's not a problem here. Then what I will do, first I will try to get the index of this current element and previous element, because now we need to get the relative value, right? I mean, if we want the rotated array. So what I will do, I will say previous equal to here it is j, so j plus rotation index. Okay, so since it is a previous value, what I will do, I will subtract 1, then I'll do a modulo n. This will give us previous element. Then current will be j plus rotation index modulo n. Then I will check if my previous element is greater than current, then for sure this is not sorted. This is not sorted, so I will return false. If such case doesn't exist at all, then finally that's a sorted one, so I'll return true. This way it will check each time the rotated array is sorted or no, and what it will do, it will generate all the combinations, and if any one combination gives us a sorted array, then we will say it is a sorted, otherwise it is not. So for each value, what we are doing, I mean, we already saw, right, it is of order n square, because we are trying to generate all the possible combinations, and then we are checking whether it is sorted or no. Then based on that, we are determining whether the array is sorted and rotated. So let's look this code in action now. Okay, so now what I will do, I will take int n equal to nums dot length. Okay, now for let I equal to 0, I less than n, I plus plus, I will check if is sorted of nums comma I. If it is equivalent to true, then I am simply returning true. Okay, then finally, if that is not the case, I will have to return false. This is my main method. Next, I will use a private is sorted. It takes int array, its nums, and then int rotation index, then again int n equal to nums dot length. Then I will use a for loop. Now our value I starts from 1, I less than n, I plus plus. What I will determine, first I will determine the previous value. So previous equal to, so basically we will have to take the nums here. So nums of our previous index would be I plus, I will copy this, rotation index minus 1 modulo n. Okay. Now int current equal to nums of, what I will do, I will copy this, take out minus 1, and now check if my previous is greater than current. If any of the value, such value exists, then we will simply return false. So if such value does not exist, at the end we will simply return true. Okay. Now let us try to run this and see. So there is a spelling mistake here. So this should be if return type, sorry, yes. So we are returning Boolean. It should be int. Sorry for that. Let's run this. Okay, it accepted. Now if I submit, so my solution got accepted. Okay. But if you see, this solution takes order of n square time. So we want to reduce it to maybe order n. Let's see, is there any possible way we can reduce it? Let us again take the example, this example, the positive case. So I will copy this. So now let us try to interpret it in a different way. Okay. Now if you see, we know, I mean, on the naked eye, this is sorted and then rotated. But if you see, this element is less than this element, means this has incremented, this has again incremented, but here there is a decrement. Then from here again it is an increment. Then again from here to here there is again an increment. Okay. So what you observed here, only there was one drop from this element to this element. Sorry, this is a negative. So there is only one drop of the, there is only one decrement from this element to this element. Otherwise, all all the consecutive numbers, they are already incremented. Plus, plus, here only minus, then again it is plus. But if you see here to here, it is again plus. So one thing would be, there will be one decrement happening. There is one decrement happening if it is a proper sorted and rotated one. If it is proper sorted one, something like this, 1, 2, 3, 4, 5, then from here to here it is plus, here to here plus, here to here plus, here to here plus, and here to here it is only minus. Correct, right? So here only one drop if you check the circular array part. So in both the case, whether the array is sorted or array is not sorted, what we are doing, we are checking it in a circular way. So from first to second, second to third, third to fourth, fourth to fifth, then from fifth back to 1. So in the entire rotation, there is only one drop. You take whether sorted array and sorted and rotated array, there will be only one drop. So that we need to figure out. If assume this is 4, 3, then 5, 1, 2. This is not a proper sorted and rotated, right?
So if you see here, from here to here, there is one drop. Here to here, there is increase. Here to here, again, there is one drop. Here to here, there is increase. Here to here, there is increase. Okay. So if you see, there are two decrements. There are two decrements. This is in case of non-sorted and rotated array. So if it is a sorted or sorted and rotated, then there will be only one decrement in the circular array if you check. Okay, maybe we will utilize that logic. Let us try to write the pseudocode for this one. So let n equal to nums dot length. Okay, so I will use for loop for I equal to 0, I less than n, I plus plus. Okay, so now how do you check whether there is decrement or no? So you will take the second element and the next element, and you will compare it with current element. So if there is the next element is less than the current element, then there is a decrement, right? So I will use that. So before that, I will take a variable next, then I will do I plus 1, but you need to do modulo n, because when it reaches the last number, that time it has to take the 0th index number as a next number, because it's a circular kind of array. Okay, so now what I will do, if this is the index we got, maybe what we can do, we can say nums of this way we will get the next number. If next number is less than our nums of I, then what we do, we will take one more variable, decrement count equal to 0, then we will say decrement count plus plus. Okay, then finally we will return decrement count is less than or equal to 1. Why? Because there should be only one decrement that is happening. That's why we will check it is less than or equal to 1. So this way we will get whether an array is sorted and decremented in order of n time complexity. And if you see, there is nothing we have used extra space, that's why it is of order 1. Okay, let us execute this and see. I will maximize this. I will maximize this window, and what I will do, I will comment out this part. Now what I will do, I will take this part and I uncomment, because we need n, and also we need decrement count, which will be 0 initially. Okay, now after this, what I will do, I will use a for loop for int I equal to 0, I less than n, I plus plus. Then what I will do, I will take a variable next, and I'll assign with the next number. So for that, nums I plus 1 modulo n. This way it will circulate over the same array. Then I will check if my next number, if it is greater than, if it is less than my nums of I, then what I will do, I will increase the count of decrement count. Okay, then finally what I will do, I will check if I will simply return my decrement count is less than or equal to 1 or not.
So with this, I will minimize and I will run this. So it is accepted and I'll submit it. If you see, our solution got accepted. Okay, this is how we solve this problem in O of n time complexity. That's it for this video. Hope you liked the content. If that is the case, please consider subscribing to my channel and also like the video and add your comments if any feedbacks you have, and share it with your friends. Thanks for watching the video.